Good morning, children. Today, let us start that exercise 2. The exercise 2 is related to fundamental theorem of arithmetic. Take down the first problem. Show that 5 into 11 into 13 plus 13 is a composite number. In this problem, we can take 13 as the common factor. If you take 13 as common factor, then we can write 13 into 5 into 11 plus 1. Next, 13 into 5 11s are 55 plus 1. Next, 13, 55 plus 1 is 56. 13 is a prime factor, 56 is a composite number. So 13 into 56 has more than 2 factors. Therefore, it is a composite number. Next problem. Using fundamental theorem of arithmetic, find HCF and LCM of 120 and 144. Now, find out the prime factors of 120 and 144 by prime factorization. Express 120 as the product of prime factors. We can write 120 as 2 into 2 into 2 into 3 into 5. 2 into 2 into 2 into 3 into 5. We can write it as 2 cube into 3 into 5. Next, 144. 144 we can write it as 2 into 2 into 2 into 3 into 3. So we can express this as 2 to the power of 4 into 3 square. Now find out the HCF. So HCF is the product of the minimum powers of the common factors. HCF of 120 and 144. Here, see the common factor 2 to the power of 3 and 2 to the power of 4. 2 and 3 are the common factor. The minimum power of 2 to the power of 3 and 2 to the power of 4 is 2 to the power of 3. In 3 and 3 to the power of 2, the minimum power is 3. So, the HCF is 2 cube is 8 into 3. 8 3s are 24. So, the HCF of 120 and 144 is 24. The next LCM. The LCM is the product of the highest powers of the common factor and the non-common factor. Here, the highest power of 2 is 2 to the power of 4 and the highest power of 3 is 3 square and the non-common factor is 5. So, 2 to the power of 4 is 16 and 3 square is 9 into 5. 16 into 9 into 5 is 720. Therefore, the HCF of 120 and 144 is 24 and LCM is 720. Next question. If HCF of 45 and 27 is D, then find X and Y satisfying D is equal to 27X plus 45Y. Here, find out the HCF of 45 and 27 by using Euclid's division algorithm. Divide 45 by 27. It divides one time. 27 ones are 27. Subtract 27 by 45. Then the remainder is 18. Next, divide 27 by 18. 27 by 18. Again it divides one time. Then 27 minus 18 is 9. Next, divide 18 by 9. It divides 2 times. 18 minus 18 is 0. Next, we can write 45 as 27 into 1 plus the remainder is 18. Next, we can write 27 as 18 into 1 plus 9. Next, 18 is equal to 9 into 2, then the remainder is 0. Since the last divisor is 9, therefore the HCF of 45 and 27 is 9. Therefore, HCF of 45 and 27 is 9. Now, express 9 in the form of 27x plus 45y. Now, we can write the HCF 9 as, so 9 is equal to 27 minus 18. Next, we can write 18 as 45 minus 27. Next, 27 minus 18, we can write it as 45 minus 27. 27 minus 45, minus into minus plus 27. So 27 plus 27 is, we can write it as 2 into 27 minus 45. 45 we can write it as 1 into 45. 45. So D is equal to 27x plus 45y. So 9 is equal to, we can write it as 27 into 2. Next, plus 45 into minus 1. Now this is of the form D is equal to 27x plus 45y. Now this is of the form D is equal to 27x plus 45y. Therefore, now x is equal to 2 and y is equal to minus 1. Therefore, x is equal to 2, y is equal to minus 1 and D is equal to 9. Next question. Show that 8 to the power of n cannot end with 0. Here, let us consider 8 to the power of n ends with 0. If 8 to the power of n ends with 0, then it implies 8 to the power of n is divisible by 5. If 8 to the power of n is divisible by 5, then 5 is a factor of 8 to the power of n. But we can write 8 to the power of n as 2 into 2 whole to the power of n. We can write it as 2 to the power of 3 whole to the power of n. Then this is equal to 2 to the power of 3n. So 8 to the power of n is equal to 2 to the power of 3n. We know, according to fundamental theorem of arithmetic, the prime factorization of each number is unique. Since the prime factorization of each number is unique, this implies that 5 is not a factor of 8 to the power of n. If 5 is not a factor of 8 to the power of n, then 8 to the power of n cannot end with the digit 0. Next question. Show that 6 to the power of n cannot end with the digit 0. Again, consider, let 6 to the power of n end with 0. When 6 to the power of n ends with 0, then it is divisible by 5. When 6 to the power of n is divisible by 5, then 5 is a factor of 6 to the power of n. But we can write 6 to the power of n as 2 into 3 whole to the power of n. Next, we can write it as 2 to the power of n into 3 to the power of n. If 6 to the power of n is equal to 2 to the power of n into 3 to the power of n, this shows that only 2 and 3 are the prime factors of 6 to the power of n. This shows that by fundamental theorem of arithmetic, 5 cannot be a prime factor of 6 to the power of n. Therefore, 6 to the power of n cannot end with the digit 0. Find the HCF of 96 and 404 by prime factorization method. Hence, find their LCM. Now, find out the prime factors of 96 and 404 by prime factorization method. We can write 96 as 2 to the power of 5 into 3 and 404 as 2 square into 101. Now find out the HCF of 96 and 404. Here the common factor is 2. The minimum power of the common factor is 2 square. So the HCF is 2 square. 2 square is 4. So the HCF of 96 and 404 is 4. Next. Now we can apply the property of the product of two numbers is equal to the product of their HCF and LCM. Now let A is equal to 96 and B is equal to 404. Therefore, A into B is equal to HCF into LCM. So, LCM is equal to A into B by HCF. So, A is 96, B is 404 and the HCF you got 4. Divide 404 by 4. 4 ones are 401. Next, multiply 96 into 101. You will get 99,696. Therefore, the LCM of 96 and 404 is 9,696. Therefore, the LCM of 96 and 404 is 9,696. Next question. Find the HCF and LCM of 510 and 92 and verify that LCM into HCF is equal to product of the two numbers. Now, find out the prime factors of 92 and 510. We can write 92 as 2 square into 23 and 510 as 2 into 3 into 5 into 17. Now find out the HCF of 92 and 510. So here the common factor is 2 and the minimum power of 2 square and 2 is 2. Therefore, the HCF of 92 and 510 is 2. Next, the LCM is the product of the highest powers of all the factors. Here, the highest power of 2 is 2 square and then 3 non-common factors are 3 into 5 into 17 into 23. If you multiply 4 into 3 into 5 into 7 into 23, you will get 23,460. So, the HCF is 2 and the LCM is 23,460. Next, verification. Now, find out the product of the two numbers 510 and 92. A into B. Here A is 92 and consider the B as 510. 92 into 510 is 46,920. And then take the product of LCM and HCF. LCM into HCF. LCM is 23,460 and HCF is 2. So 23,460 into 2 is 46,920. Therefore, A into B is equal to LCM into HCF. Therefore, the product of any two numbers is equal to the product of their HCF and LCM. Next question. If A and B are relatively co-prime, prove that LCM of MA and MB is MAB. Here, A and B are co-primes. Since A and B are the co-prime, then the HCF of A and B is 1. Next, let us consider MA as capital letter A and MB as capital letter B. Next, we know the product of two numbers is equal to the product of their LCM and HCF. LCM and HCF. Therefore, LCM is equal to A into B by HCF. A is MA and B is MB, and HCF of MA and MB is M. The HCF of A and B is M. Here A is MA, B is MB. The common factor of A and B is M. Therefore, the HCF AB is M. Next, here we can cancel this M. Therefore, the LCM is MAB. LCM of MA and MB is MAB. Next question. A sweet seller has 420 Kaju Barfis and 150 Badam Barfis. He wants to stock them in such a way that each stock has the same number and they take up the least area of the tray. How many of these can be placed in each stock? How many stocks are formed? Here, to find the maximum number of burpees in each stock, we have to find out the HCF of 420 and 150. Now, find out the prime factors of 420 and 150. Now, we can write 420 as 2 squared into 3 into 7 and 150 as 2 into 3 into 5 squared. Next, find out the HCF. Here, the common factors are 2 and 3 and the minimum power of 2 square and 2 is 2 and 3. So, the HCF of 420 and 150 is, so the HCF of 420 and 150 is the product of the least powers of the common factors. Here the common factors are 2, 3 and 5. The minimum power of 2 square and 2 is 2 and 3. So here 5. So the HCF is 30. Next, find out the maximum number of burpees in each stock. Therefore, the maximum number of burpees in each stock is 30. Next, we can find out the number of stocks by dividing the number of burpees by HCF. Therefore, the number of stocks is equal to 420 plus 150 divided by 30. 420 plus 150 is 570 by 30. Cancel the 0. Divide 57 by 3. It divides 19 times. Therefore, the number of stocks is 19. Next question. Ravi and Shika drive around a circular sports field. Ravi takes 16 minutes to take one round while Shika completes the round in 20 minutes. If both start at the same point at the same time and go in the same direction, after how much time will they meet at the starting point? Here, to find the required time, we have to find out the LCM of 16 and 20. Now, find out the prime factors of 16 and 20. We can write 16 as 2 to the power of 4 and 20 as 2 square into 5. Therefore, LCM of 16 and 20 is the product of the highest powers of all the factors. Here, the highest power of 2 is 2 to the power of 4 and 5. So, 2 to the power of 4 is 16 into 5. 16 into 5 is 80. Therefore, both will meet at the starting point after 80 minutes.